All right, we're back at Exponent Laws, round 2. So we're going to start by taking a look at a to the power of 3. So we talked about last time what that looks like as repeated multiplication. So let's go ahead and do that. A to the power of 3 is just a times a times a. Okay, that's easy enough. So what if a was something else? Like what if a was, say, a power? Say 4 squared. So let's replace all the a's with 4 squared. So instead of a to the power of 3, we had 4 squared to the power of 3. It still means the same thing. They still want whatever is inside those brackets to be multiplied by itself and then multiplied by itself again. So instead of a times a times a, we're going to have 4 squared times 4 squared times 4 squared. Okay? Now let's write this as repeated multiplication. So let's break down these 4 squareds even further into 4 times 4. So each of these 4 squared represents 4 times 4. So that's one of them. It's being multiplied by another 4 squared, so that's 4 times 4. And it's being multiplied by another 4 squared, so that's another 4 times 4. Okay. So we take a step back and look at this. This is just a bunch of 4s being multiplied together. So how many 4s do we have? We have 1, 2, 3, 4, 5. That's 6 of these 4s. So we can rewrite this as a single power, as 4 to the power 6. So if you take a look at these exponents, let's see if we can come up with a shortcut. So we start off with 2 as an exponent, and we had another 3 there as an exponent, and we ended up with 6. So as you can see, what's happening is we're just multiplying these exponents, and that gives us our the exponent on our single power. So let's take a look at what the exponent law says. It says that when a power is given an exponent, right? So we took something that already had an exponent, we slapped another exponent on it. Okay, we call this a power of a power. Okay, so we started with a power and we put another exponent on it, so we call that a power of power. We can multiply the exponents together to rewrite it as a single power, which means that if I had something like a to the power of, let's say, m. Okay, so that's my first power. And then I decide to make it a power of a power, meaning I slap another exponent on there. Okay, so I want everything inside the brackets to be to the power of p. A quick way for me to turn this into a single power is to just write it as a to the power of whatever m times p is. And that's exponent law number 3. So anytime you see something to the power of an exponent, and then that is then raised to another exponent, you can multiply those exponents together. So let's take a look at some examples. 3 to the power of 2, and then the whole thing is to the power of 4. So 3 to the power of 2 to the power of 4, okay, what we do is we just multiply these exponents. So it's going to be 3 to the power of whatever 2 times 4 is. Well, 2 times 4 is 8. So this is 3 to the power of 8. All right. It's pretty simple. Let's take it a step further. Let's take a look at what we have here. This is 5 to the power of 2, and then the whole thing is to the power of 3. Then we want to multiply this by 5 to the power of 3, and that whole thing is to the power of 4. So if we take a look at these individually, so let's focus on just this part right here. Okay. This is 5 to the power of 2 to the power of 3. Well, we know how to deal with that. We just multiply the exponent. So let's go ahead and do that first. That's going to be 5 to the power of 2 times 3 is 6. So we do that. Then we go in and take a look at this piece right here. And this is 5 to the power of 3. And the whole thing is to the power of 4. Well, we know how to deal with that, right? We just multiply the exponents. So let's go ahead and do that. That's 5 to the power of 3 times 4 is 12. And these two things are being multiplied together. And if you remember from last time, we learned about this exponent law where if we're multiplying powers with the same base, that we can just add the exponents as a shortcut to get a single power. So this is going to be 5 to the power of, well, what's 6 plus 12? It's 18. And there you go. Okay, so that's exponent law number 3. Let's move on. We're going to take a look at another example here. Okay, so we have 5 times 4, and then the whole thing is raised to the power of 3, which means I want everything inside the brackets to be multiplied by itself and then multiplied by itself again. So I'm going to go ahead and do that. So that's what I did here. Right? So I have one set of brackets, another set of brackets, and another set of brackets. Right? I'm just doing what the exponent of 3 wants me to do. Multiply everything inside by itself, and then multiply by itself again. If I then take a look at this, this is all multiplication. So these brackets, I don't really need them. So I'm going to drop the brackets. I'm going to end up with 5 times 4 times 5 times 4 times 5 times 4. And because this is all multiplication, I'm just going to rearrange these. I'll put all the 5s together, and I'll put all the 4s together. So that's what happens here at this step right here. And I'll put all the 5s together, and I put all the 4s together. Okay. Well, there's another way to write 5 times 5 times 5. That's 5 to the power of 3. And there's another way to write 4 times 4 times 4. It's 4 to the power of 3. And so I started with 5 times 4, and everything is to the power of 3, and I ended up with 5 to the power of 3 times 4 to the power of 3. This is called the product of powers exponent law. So it says a power of a product, which means if I slap the exponent onto some multiplication, okay, that's a product, it can be rewritten as a product of powers. What that means is I'm going to end up with 2 powers that are multiplied together. So in general terms, it's going to look like this. If I had something times something, so A times B, and this whole thing was being raised to the power of m, I'm going to end up with A to the power of m times B to the power of m. So I like to affectionately call this the Oprah Winfrey law. Okay, we had A times B, and the whole thing is being raised to the power of m. So what ends up happening is you get an m, you get an m, everybody gets an m. And so let's take a look at some examples. We can blaze through this. This is going to be real fast. 3 times 5 to the power of 2. Okay, cool. Let's use the exponent law. Right? You get a 2. You get a 2. Okay, everybody gets a 2. So we end up with 3 to the power of 2 and 5 to the power of 2. Okay, there we go. We have a product of powers. Okay, over here, 4 times 7 to the power of 5. So you get a 5, you get a 5. Okay, everybody gets a 5. So we end up with 4 to the power of 5 times 7 to the power of 5. Okay. Finally, this Oprah Winfrey law has a variation on it where if we have some division, like here we had 5 divided by 4, or 5 over 4, okay, and the whole thing is raised to the power of 3. Same thing, raising something to the power of 3 means take everything there, multiply it by itself, then multiply by itself again. And so that's what I've done on this first line here. 5 over 4 times 5 over 4 times 5 over 4. Then I take a look at it in terms of all the tops and all the bottoms. What I have on top is just 5 times 5 times 5. And on the bottom, I have 4 times 4 times 4. Well, there's another way to rewrite 5 times 5 times 5. That's just 5 to the power of 3. And there's another way to rewrite 4 times 4 times 4. That's just 4 to the power of 3. And so in a similar fashion, okay, we're just taking a quotient, which is basically something divided by something. So A divided by B. And the whole thing is raised to the power of m. We're going to end up with A having a exponent of m and B having an exponent of m. Okay? So it's Oprah all over again. You get an m. You get an m. Okay? Everybody gets an m.
Everybody gets a car!
So let's do some quick examples, and then I'll give you guys your homework assignment. So here we go. 2 over 3 to the power of 4. Okay, you guys should be able to do this in your sleep now. This is going to be, you get a 4. You get a 4. So you get 2 to the power of 4 and 3 to the power of 4. Okay, and that's how we end up with a quotient of powers. 12 over 17. The whole thing is to the power of 3, right? So you get a 3. 12 to the power of 3. You get a 3. 17 to the power of 3. And there you go. We're done. So we can use the exponent laws to take these expressions and rewrite them in a different form. Okay, and so for your assignment, I want you guys to work out of your textbook on page 106. We're going to do numbers 14 all the way up to 16, so I want you to do 15 as well. And then we're going to tack on 19, 21, and 22. Okay, that's it. Go get them.